turning them in saying there's extras. They never got them back to people in the back.
Are you yelling at me?
It's all right. He's not crying.
Hey, I'm not crying.
Yeah, they can't.
I watched this on.
Okay, so we're gonna start with yesterday's and we'll go on that. Alrighty. Shh. Glad is here. We need to do well on this test. Tomorrow when you get the test, the only thing you're gonna get, in fact, if you have a calculator, you're gonna put a Post-it with your name on the calculator, and you're gonna have to put it on the cards up here. And I'm gonna give you one sheet of paper with 6, can't use a calculator for it, snail shell problems. That's what that front page is gonna be. When you bring your test up to me, and I can see that you're done with it, then you can grab your calculator and you'll get the second part of the test, which is the rest of the stuff. So yesterday we covered 1 through 11. We are now on 12. So it says write each equation in logarithmic form. Now what that means is we have to unsnail shell this and figure out what it said before they snail shelled it. Right, Forrest?
I'm setting a reminder to bring my calculator. I am.
I asked everybody to put the phones away.
Oh.
You'll have to write yourself a note. See,
See, like what?
you'll have to write yourself a little note to put it in there later.
Can I finish now?
Because it was already distracting Cody.
Now you're distracted. Yeah.
Now you're
Now you're
distracted.
distracted.
It didn't pause. It didn't pause at all.
Honestly,
Well, that's all on there.
Oh,
All right, let's unsnail shell this. This said log something equals something to the something. So we're unsnail shelling. We didn't.
I haven't done.
You were working ahead. Michael was working ahead,
Really low.
Which of these would be the base?
11.
11. To the what?
Third.
Equals.
1, 3, 3, 1.
There it is. Mouse thing's in the way. There it is.
Oh, absolutely.
So, once I get that written, if it looks awkward, here's what I do. Some of you know what this is. On your pencil, you have a little pink thing that's called an eraser. And if it looks awkward, you say to yourself, self, I should rewrite this because this is a test and make it look perfect. That's what you do.
Wait, what did we do wrong?
It was all squashed.
So do we get minus points?
If I can't tell what it is. Yes.
Oh.
So it's gotta be readable.
This
Gotta
is
be
bogus. I
readable.
was planning on doing Spanish.
That's a.
You don't know enough Spanish.
Alrighty, let's look at
Math, so you- yeah, it's math.
13.
Yeah, exactly.
Logarithm, something equals something. There it is. So we need a base. We need what goes over here and what goes over here. What's base?
5.
5. 5 to the what power?
0.008.
0, 0, 8.
Oh, negative third, my bad.
Oh, yeah.
Equals.
0.008.
0.008.
And again, that's kind of squashed. So I'd probably say, you know what? I know what the numbers are now. Just rewrite it so it's not all squished and messy. So there's no way for me to not know what you wanted for your answer. Oh my goodness, 14 is scary. Megan. No, and here's why. All we're supposed to do with this is write it in logarithmic form. That's it. Then stop. It doesn't say write in logarithmic form, then expand or anything goofy, you know? So we just stop right there. All right, 14. Log something to the something. What's the base? It is x. Here's your power right here. Raised to what?
See.
The z equals, remember it has to work forwards and backwards, so if you get to this point and you snail shell it and it doesn't look like that, you know you're wrong. Now I would probably slap some parentheses there just to show, hey, these two things should stay together, Wouldn't have to. I'd give you points without a but. Would be nice. Again, when you snail shell this, it has to be a perfect match. X to the Z equals Y over W. All good. Okay? Well, now there are steps to complete. Because this says, write each logarithmic expression as a single logarithm, and just so that everybody knows, I put the little condense there so that if you just want to think of it as condensed instead, you've got that. All right. Log 7 minus 2 log 3. First step. Put the 2 back up. Sounds like a good plan. Log 7 minus log of 3 squared. Hey, do we know what 3 squared is?
9.
It is 9. Earbuds out. Too many people with earbuds in. Pay attention, listen. How about subtraction? What's that? 7/9 reducible? No. Is 10 to the something equal to 7/9? Is the something nice? Oh, not a chance. 10 to some power of 7/9, so we know we're done. That's the last thing we have to check. Can we simplify this anymore? So, no go. Next one says log of x minus log of xy. What you thinking?
I mean, I think we can go into this.
Okay. Simplifiable.
Yeah.
Why?
X's cancel.
Yes, they can, but remember when you cancel, you have to leave a little 1. So it'll be log of 1 over y. Way too many people always tell me that's log of y. Nope, there's a 1 on the top. Log of 1 over y. All right, I got to scoot this thing over a little bit. Will it let me scoot? It will.
Oh, this is crazy.
What do you think?
Put that one half and then
Put the 1/2 back for what?
both
Oh,
of them.
yeah.
So why not put the other 2 together first?
That's a
It
good
does.
idea.
That way you don't have to write down the 1/2 twice. It just is a little bit easier. So you kind of follow the order of operations. Now let's put the 1/2 up. But both of them are getting the 1/2. So we have to use parentheses there. And it turns out this one's not done. Because we have to know what 1/2 power does.
Square.
Flips it. Negative.
Square.
Square root. Square root.
I'm surprised.
Yeah, Carson said that right.
Was that Carson?
It's okay. I didn't hear it. Carson's out.
I thought it was Jeff.
I heard him say it right away.
Carson got it.
What can't this
What?
do?
Exactly. Math saving orange.
What can't
Wait, Z.
Why are we square rooting it? Why are we square rooting it?
Because 1/2 power is the same thing as square root. The square root of x is x to the 1/2. The cubed root of x is x to the 1/3, etc.
So
That's
I feel
why.
like 1/4.
Yep.
So it was like 1 over a number.
Alrighty, to the back page.
I'm not
Now it says expand.
Oh, I'm getting the cough already.
Make 2 of them?
Three.
3 of them?
2.
So what do we do?
Well, it's obvious.
Well, that's
All you gotta
subtraction.
do is
Nick
subtract.
Goldberg, that has turned out to be a very bad spot for you. Go back to your seat,
Second chance, second
please.
chance.
No, no, no. No second chances. You had your chance. You need to move. What's the big picture of this?
Subtraction.
It is, because it's division.
Well, there's gonna be addition in there too.
Well, how come?
Why do we have to take away the 4 and
We do. We do. This 3 comes in front? What do you mean it's 2? It says logarithm base 2 of 4. That's 2? Yes, snail shell it in your head. 2 to the something is 4. Catch. Good catch.
That is
Eight
based on
travel.
this.
It's a 2. What do you think?
Wait.
Oh,
Plus
that's
X to the 1
oh, that's
power.
Okay, who said the x to the 1 half? How'd you know it, Chris? Square root. 1 half power.
He knows everything.
I'm not speaking this.
He's the almighty Carson.
So what do you do with the 1 half?
You put it in the front.
Put it in front. Bad looking x. Now there's a reason I didn't write anything down for logarithm.
It's 2.
That's 2. 3 squared equals 9. When you snail shell it,
Plus,
there it is. Plus 2. Can I erase? Anybody need more time? Okay. So if it just has numbers, notice in both of these, base is a number, the number we're trying to evaluate is a number. You have to take a look and see if you snail shell that, is it something else? If it is, make it the something nice. If it's not, you just leave it. 20? You're overthinking.
You just type in your calculator.
Okay, move this up now. All right. Little thing called the change of base formula to evaluate the logarithm base 3 of 8. But here's the deal. The instructions say use the change of base formula. So I have to see what you're punching in.
yeah.
I
know
know
that
question.
It's
I
just
feel like
snail shell.
once you tell me it, I'm gonna be like, oh, I know what that is.
It's
But
snail
as of right now,
Snail
What's the
shell?
change of base formula?
Snail shell.
No.
That's so simple.
It's
No,
snail
close.
shell.
It's
Just put it.
Oh.
Aaron, was that you?
Oh, yeah.
Is that you, Aaron?
I just stated what it was.
Yeah, logarithm of the big number you're trying to evaluate divided by the logarithm of the base.
That's it?
Then it's calculator time.
No, me neither.
That's the change of base formula.
Makes sense. Pretty self-explanatory.
Do you write x equals or doesn't?
Oh, just give me the number. 4 decimal places. 1.8928.
1.8.
Because we don't have any x equals or anything in this one, so. That is the change of base formula. It is the logarithm of the large number you're trying to evaluate divided by the logarithm of base. That's it. Notice how we forgot that because it was too easy. That happens.
That wasn't.
Well, we just didn't know what to change it based on.
And that's, you had a whole assignment where you, in fact, most people, all they had was answers, no work, because you knew exactly what you were doing. But when something's too easy and we don't do it again and again and again, our brain says, out.
Yeah, that's true.
Huh. Graph each function.
What if I wouldn't have to grab?
Well, sure we do. We graphed inside.
Didn't you do the first assignment?
Graph each function
Graph each
showing
function.
the parent function and then the translation. Graph it, use at least 3 points for your table. Now, for me, that's the first thing I'm gonna do. Because I'm a right-handed snail sheller.
What was the first assignment?
7-3.
Is that the one?
Because we need to snail shell this if we're gonna graph it.
Oh, that's what
3 to the y equals x. So do we put in x's or do we put in y's?
Put in Y.
We do. We don't need a lot of negatives because negatives are giving us fractions. And I know it said 3, but this one is best graph with 4. You'll see why. And 4 is usually a good idea. So 3 to the negative 1. What's that? 1/3. Remember, it flips it. Negative powers flip it. 3 to the 0. 3 to the first. 3 squared. Now don't graph backwards. Graph them just as they are. Now it says graph the or show the parent function and graph the translations. Did this one have translations? No. Because this is supposed to be y equals logarithm base b of x minus h plus k. There's no h and k, so this one's solid. We don't have to dash anything on this one. 1/3 negative 1, 1, 0, 3, 1, 9, 2.
Wait, were you that?
If we have an h or a k that we have to translate. But this one doesn't have a translation. Now, also make sure you have arrows on both ends. This keeps going forever, does not stop. Domain, range, and asymptote. Let's actually start off with the bottom one there, the asymptote. Where is the line for this that it's never going to cross? The y-axis. But we need an equation for that. An equation for that line. Doesn't cross the y-axis. Crosses the x-axis. Remember karate chops, the x-axis, x equals 0. So if it's never going to cross it, and it's never going to reach 0, are we ever going to use all the x's over here on the left? Nope. So it's going to be x is greater than 0 for the domain. With arrows on the two ends, is this going up and down forever?
Yes.
Going up kind of slow, but it's still going up. See my double R there. There it is. So this one didn't have an H and a K. Not that we can't handle H and K, because in the next one we can, and we'll do it very well. But if it doesn't have one, then we don't need to have a dashed or a dotted. It's just, hey, here it is. I don't have to move it anymore. So let's go to the one that's a little more complicated. That's this one. All right, so if you missed it before, because I know some of you had your head down graphic, that's what a logarithm with an h and k looks like. But the h has to be in the parentheses with this, so you have to pay attention to this. So logarithm base b of the quantity x minus h plus k. So do we have an h or do we have a k? We have an h. Nick, start writing. What is h?
Have that one down.
I am writing. I'm writing.
I can't really
Wait, how'd that
Very
be?
rare talent of
Why
mine.
is all this
Master.
stuff not
Show us.
Show us.
Okay, show us, Nick.
What's h?
Goes to the left.
-2. Good. What does that mean? Where's this graph going to move? To the left. So this time we're going to have a parent function. And the parent doesn't use h and k. So it's like you just take this right off, because we're going to take care of that later. And it's going to say logarithm of x base, sorry, I got to make my x bigger, equals y. And there's no base. Or is there?
10.
It is a 10, exactly. We don't get anything by our little log, it's base 10. Snail shell that, what does it say? 10 to y equals x. So that's our parent. Whatever we get from that snail shelling is our parent. And just like the last one, I'm just going to go ahead and use -1, 0, 1, and 2. We may not graph them all, but at least 10 to the negative 1 is, negatives do what?
1/10. Whatever.
Flip it, 1/10. 10 to the 0, 10 to the first, 10 squared. I'm not graphing 100, but it gives me something to aim at, something to see where it's going to go. So let's graph this one, but this is dashed or dotted because this is not our final product here. We have a translation on this one. We got to move it. It had a +2 up here. And we talked earlier about what that's going to have us do. So that means our asymptote is going to move to the left. It was at 0. Not anymore. What's the equation for that one? Careful. -2. Now we are just going to move it 2 units to the left and make it solid. And put some arrows on it. To the left, arrows. X is greater than -2. Yeah, new asymptote, new cutoff. X is greater than -2. Okay, I can see it's going down forever, and so could you. But is this one really going to go up forever?
Yeah.
How do you know that?
It's going up.
Now it's going really slow because it takes it till 100 before it goes up, but it's still going up. And if we go forever, it's going, gone. So it is all reals. That's the test with different numbers that you have in front of you from yesterday and today. That's the reason that Mike didn't get one.
Oh, yeah. Hey, that's mine.
You wrote on yours.
Ah.
All right. Take a second look at everything on that practice test and see if there's one where you're saying, "Ooh, I'd like to see just one more of those."
Now we get it. We should be good.
19. Number 19. Oh, that's a good one. I like that one. So I'm going to make a problem up like 19. So we'll just call this problem number like 19. There we go. Let's see. What could we put? We could do this. Expand. X to the 1/3. We okay with that? Yeah, cube root is 1/3 power. Split them up? Out. One-third in front of that term? Oh, that's every time. Oh, this is a number? It is. 4 to the 3rd is 64. Now it's expanding. So square root, 1/2 power. Cube root, 1/3 power. Fourth root, 1/4 power.
I have a question.
Etc. And then
So if it was condensed, will we start?
we start here
Try to go there.
and work back to this.
How to do that?
Exactly in reverse. Oh, except this
But
piece.
yeah, that.
And see, that would be the problem, because there's an infinite number of ways to write 3 with a logarithm. We probably wouldn't get exactly this, but we would get something close to it. What would happen on the test would be more like you won't see this last step, you'll see that one. And then you have to put it together. Because that 3, that just messes up the works. Because it could be logarithm base 2 of 8. That's, it could be logarithm base 3 of 27. There's an infinite number of possibilities. Any others? Take a peek. Another one of something. First page. Why don't I just make up a new one? Because, oh, let's see. The toughest thing for everybody yesterday was things that involved negatives and fractions, right? So, let's start with this. Start with that. Exactly. One's a fraction and one's not. So how did it get from here to here? It has to have a negative. Yes, because 3 squared.
I said 2.
So the 2 toughest concepts for everybody seem to be if we're taking square roots, cube roots, fourth roots, and the negatives. If one side's a fraction and the other's not, it has to be a negative because negatives do that. Some people wouldn't appreciate that because this is not a calculator. Some of them have a tough time with that power stuff. Okay, let's try. Let's do both fractions. Let's do that because I don't think we did any fraction. Oh, we did one. Snail shell. Do we need a negative to flip it? No. Is it 4? It is, because you raised 2 to the 4th power. I remember some of these seem harder for you guys. No? Snail shell? Oh my goodness, bless you.
Negative 3.
Negative 3. Flip it. Negative 3 to the 3rd. 27. It's X. Inverses.
Is there going to be one like
How is it
that?
in inverse?
There'll be something where there's perfect inverse.
Okay. That might just trigger me up.
What does that say? Big black box.
5.
It says 5. 5. This is logarithm base E. When the bases match, boom. Inverses of each other. Anything else from the practice test?
So, wait, I have a question.
Yes, Emmanuel.
So is it because log 2?
Yep. These 2 bases, this is the base for the logarithm and the base for the exponent. Those are the same. Drop right out. All right, quit recording at this point. What is this little trash can thing you doing? In the way.